Today we're going to talk about the most important things you need to know about biomass, this very broad, complicated category. And so, in honor of that, I've got biomass in my background. I've got my flower earrings on. These are all examples of biomass. Biomass is a renewable energy resource, meaning that we can utilize it and it can replenish itself. We put it in this category of semi-renewable because it is a challenge to maintain a biomass resource sustainably. In other words, we have to use it at a rate where it can replenish itself. And oftentimes we will see examples of a biomass resource being used faster than it can regenerate or replenish. There are different categories of biomass. It's a very complex, complicated category that covers a lot. So one of the ways we characterize biomass is whether it's traditional biomass or commercial biomass. Traditional biomass is people using biomass they've collected themselves, whether that's wood or animal dung, for their own energy needs, often heating, lighting, and cooking. And so 2.8 billion people in the world are still using traditional biomass for many of their energy services. That's traditional biomass. Commercial biomass is a different category. This is where the biomass is bought and sold. And it is much more accurately tracked. And a lot of our charts and our data is about commercial biomass. Traditional biomass is much harder. We have to do a lot of assumptions to figure out the quantity of that. Within those categories, the biomass comes in kind of three main flavors: solid biomass that we're using directly, liquid biofuels that we're transforming a solid biomass into a liquid. We're using that primarily for transportation. And then biogas, where we're converting solid biomass into a biogas that's basically a renewable natural gas. And then we can use it for all the same things we can use natural gas for. Another way to categorize biomass that's really important, because if we're thinking about the environmental impacts and the carbon benefits of biomass, it's important to think about what is that solid biomass? Where did it come from? And so another way to divide it up is whether it's a waste stream or it is a forest or crop or energy crop, something like that. And so there's going to be very different environmental impacts depending on which category it falls in. So just to give you a variety of what that biomass is, it's wood, it's crops, it's agricultural residues, it's industrial residues, it's municipal solid waste, it's animal waste. All of this fits into that biomass category. We use biomass in all sectors. We use it for heat, we use it for transportation, and we use it for electricity production. You can see it's a relatively small wedge, both in the world and in the United States, both for energy use and for electricity, but it is used in all of these categories. Looking at the global scale in terms of how much we get for energy services, you can see about 12% of our energy services are provided by biomass, and half of those are traditional biomass. So this is including the traditional biomass that people are collecting for themselves. The other half is the modern bioenergy, and that's where we're using it for heat and industry and buildings. We're using it in transportation. We're using it for electricity production. But you can see it's a relatively small portion of the energy needs of each of those sectors. Heat and using commercial biomass for heat is really something that's not growing a lot. It's a flat industry in terms of using biomass for heat. We see this being done for district heating, for example, in Europe. Industries using waste streams for their heating needs, but not a lot of growth happening here. It's a little bit different when you're looking at what is happening with biomass for electricity generation. We are seeing growth in biopower or bioelectricity, where biomass is being used for electricity generation. We're seeing a lot of that growth in China, but we're actually seeing some growth in Europe as well as part of their efforts to rely more on renewable energy. Most of the biomass used is solid biomass, and that makes sense. That's how we're collecting it. In order to use a liquid or a biogas, you start with a solid and you create that. Liquid biofuels are really only going to be used in transportation. It takes energy to transform them to a liquid. Biogas is going to be used anywhere we're using natural gas, but most of what we're using is the solid biomass. Bringing it to the United States really quick, just to look at how much of our renewable energy we get from biomass, it's over half, and about half of that is for biofuels for transportation, and the other half is for heat and electricity production. It's used in all sectors. So like I said, our solid, both our waste and our wood streams are used for heat, residential, commercial, industrial, they're used for electricity production. Our biofuels are really just going to be used in our transportation sector. So one of the categories that it's important to think about is the impacts of this use of biomass. And it really largely depends on what is the source. So I'm just going to give you some flavors of that. One is wood pellets. So wood pellets are what Europe is primarily using for powering their biomass power plants, and that in part of their transition to renewable energy, they're using wood pellets to run their thermal power plants. Many of those wood pellets are coming from the United States. So the production of wood pellets have grown a lot in the United States, mostly in the Southeast, and now the US is the largest producer and exporter of wood pellets, with much of those wood pellets going to Europe. This is a pretty controversial thing, but demand for it is growing. And the reason it's controversial is the carbon neutrality of that biomass. So studies have shown that when we're doing like wood collection or a lot of biomass collection, and then counting on regrowing that in order to recapture that carbon emission, it's really only carbon neutral on long time scales. So in other words, if you're cutting down trees and burning them for power today, it's going to take decades to a century for a replacement tree to absorb that same amount of carbon. And in the meantime, for that century, all of that CO2 is contributing to climate change. So if we're looking at trying to reduce carbon emissions in the next 10 years, 20 years, 30 years, these aren't carbon neutral strategies. One of the ways that people have talked about making it more carbon neutral or carbon negative is something called BECCS, where now we're taking those wood pellets, we're burning them to produce power, and we're doing carbon capture and sequestration. So we're taking the CO2 out at the back end. It still has a lot of the same challenges and thinking about it, and this isn't really being done anywhere. It is just in theory because carbon capture and storage is another energy intensive process that adds cost to the power plants. Another biomass that we can use not just from our trees is from our animals. So our farm animals, our cows, our pigs, our chickens all produce manure that left alone will release a lot of methane, which is a very potent greenhouse gas, but we can actually collect that and use it as an energy resource. So the chart I'm showing here is just for the United States, but this is for methane emissions. Methane is about 20% of our greenhouse gas emissions globally. You can see that manure management, that's the stuff that's coming off the poop, is about 10% of that. This other part is actually primarily from cows burping. That is something that is much harder to collect as an energy resource, but there are companies that are looking at ways of reducing methane emissions from cows burping as they're eating. So how do we take that animal waste and make it into an energy resource? The best way is to do something called a digester. And what it is an anaerobic digester. In other words, there's no oxygen in it. So you collect that animal waste, you put it in a tank or a filled lagoon or some container where you're keeping the oxygen out. And by keeping the oxygen out, all of the enzymes and microorganisms, as they digest that animal waste, will create natural gas. It's a natural gas that, depending on how good your digester is, it's not quite as energy intense as natural gas we get out of the ground, but it's the same thing. It's methane. And you can actually clean that up. You can put it into the pipeline if it's pipeline quality. You can just burn it directly for heating. You can burn it for electricity production. It burns relatively cleanly compared to burning a solid in terms of the air pollution impacts. So in the United States, we've seen growth in using that manure-based natural gas, that manure-based methane for things like compressed natural gas, which we're often using that for transportation, or for pipeline renewable natural gas, which is meaning you're just cleaning it up a little bit and actually putting it in the pipeline and using it instead of fossil fuel natural gas. Another resource we can use is solid waste and municipal solid waste, which globally and in the US, I'm just showing the US example here, we have a lot of municipal solid waste. In the United States, we're generating, 5 pounds of trash per person per day, and half of that is going to landfill. And so that half that's going to landfill is an opportunity to utilize as a energy resource. There's kind of two main ways we can use that as an energy resource. We can burn that landfill municipal solid waste directly. That's solid waste incineration. Challenges there is that it has a lot of air pollution because you're burning everything that's in the municipal solid waste. Countries that have a lot of land use limitations rely a lot on this to reduce the amount of land that they have to use for municipal solid waste. So Scandinavia and Japan, some of the states in the United States like Florida that are very land limited, use a lot of solid waste incineration to reduce those land impacts. Landfill gas, which is where a lot of the waste is going, that's where we're burying our municipal solid waste in the ground. You have to collect the methane that's coming off of that landfill. So when you bury it in the ground, you're basically making an anaerobic digester. That waste is going to digest and form methane, and you don't want that methane to form in pockets and cause explosions. So you have to collect the methane. You can just vent it, which is bad as a greenhouse gas. You can flare it, which is a little bit better, but you're not making use of that energy. Or you can actually collect it and produce electricity or use it for heat or something like that, but something that's productive and reduce the impacts of that methane that's being created with our landfill gas. Finally, just a last category of thinking about biomass is thinking about biofuels. And we'll talk more about this if you want to know more about biofuels. Check out our 10-minute take on biofuels. So what I want you to take away from today about biomass is it's complicated. It includes our trees, it includes our crops, it includes industrial waste and municipal waste. The good thing about biomass is it's available almost everywhere people are, so it is a very available resource, and we can use waste as a fuel, which tends to be a lower environmental impact resource. The bad is that you're burning it just like you would a fossil fuel. And so you have air pollution, you have greenhouse gas emissions, you have those environmental impacts, and you can have significant land use, water use, fertilizer use, and competition with food that can make it really challenging. And remember that it is one of those resources that we have to use wisely and carefully in order for it to be sustainable, particularly when we're talking about our forest or our crop, anything that's using land, not as much for our waste streams. So for it to be renewable and sustainable, we have to really think about how we're doing it. Okay, so that's kind of a primer on biomass and energy from biomass. If you want to know more, check out our full lecture. And if you just enjoy learning about different energy resources, check out our energy spotlight.